Hello, we are going to do a tank problem out of 4.1 here. And I'll let you read through the directions, and I'm going to add the given rates that it mentions in the problem here. And if you want to take the opportunity to pause this video and try the setup yourself, and then you can unpause and I will go through the whole setup of this with you. So the first given rate here will be rate 1 of 10 gallons per minute. And the other will be over here, rate 2, which I kept those notations the same as they were in class. And rate 2 is equal to 12 gallons per minute. And then you also will need the outflow. I'm sorry, I think I have to give you all of them. Okay, which is why I didn't include it in the directions, because there's a lot. So that's the first inflow here for tank 1. The second is coming here from tank 2. So that is called rate 4, skipping around these numbers a little bit. That is 6 gallons per minute. Okay, and then the other inflow here to tank 2 is coming from tank 1. That is rate 3 at 2 gallons per minute. Oh my goodness. Sorry, it does automatic shapes here. Okay. And then the last ones that I have to give you here would be the outflow coming from each tank. So let's see, we have rate 1, 2, 3, 4. This would be rate 5 equal to 4 gallons per minute. And rate 6 equal to 8 gallons per minute. So like I said, if you want to take the time, pause it right here and see if you can write the system of differential equations. All right. Assuming that you took the opportunity to do that, let's go through it together and make sure you have it down. So first thing I'm going to do is actually find the volume functions for each of these tanks. Once you have the inflow and outflow rates, you can write the volume function. So the volume of tank 1 at any given time will be what it initially contains, which is 200 gallons of fresh water, and that goes to the concentration. But it's a starting value of 200. And then every minute, there are certain amounts flowing in, certain amounts flowing out. We see that going into tank 1 here at rate 1 and rate 4, we have 16 gallons per minute flowing in. The outflow would be rate 3 and rate 5. And we see combining those, we have an outflow of 6 gallons per minute. So 16 gallons per minute coming in, less that 6 gallons per minute going out means that I am adding 10 gallons every minute. So my volume function for tank 1 is 200 plus 10T. Now, same thing for volume of tank 2 per minute. I look at the initial 50 pounds of salt, that's the concentration dissolved in 300 gallons of water. So initially 300 gallons of water. The inflow with rate 2 and rate 3 would be 14 gallons per minute. The outflow with rate 4 and rate 6 would also be 14 gallons per minute. So we have a constant volume function for tank 2. Now, one thing I do want to point out, and I did not do this in class, but it does ask you on the assignment to talk about the pertinent information for T. So we do have an interval on which T exists here because of the volume of tank 1. It will get to a certain point where it reaches the capacity of 500 gallons and it will be full. We won't be able to pour more solution into this tank. So what we have to do is solve that volume function. Oops, I included a T where I shouldn't have. Let me try again. We need to solve that volume function for T to find when it reaches max capacity of 500. So 10T equals 300. And it looks like that means that T will be equal to 30 minutes. Now that's when it reaches max capacity, but we are starting at time T equals 0. So the interval that we are interested in for this problem will range from 0 to 30. And luckily you have a 2-tank system that, shuts off at 30 minutes when it knows that that tank is at capacity. All right. So just beware of that in the problems that you see in your assignment. All right, now, tank 1 contains 200 gallons of fresh water, and I'm realizing that I did not give you a concentration for that. I'm looking at it now. I'm sorry. I gave you the concentration for tank 2, which is that you have fresh water coming in. So if you were unable to write that as a constant, hopefully you set it up with C sub 1, concentration sub 1. Sorry if that was giving you an issue when you were trying to set it up. C sub 2, since it notates that we are, where did I see that? Oh my goodness. Okay, I'm sorry. Tank 1, I was supposed to give you the concentration, and tank 2, I was supposed to tell you that we had fresh water coming in. So I apologize that I didn't include those. I thought I just had to include the rates for you. So if you didn't, obviously you didn't have those, but if you just had them as variables, hopefully you still got the correct setup, but now we can just plug those numbers in. For C sub 1, that should be C sub 1. So the concentration flowing in over here, I should have told you that that will be 1/2 pound of salt per gallon. Okay, so C sub 2 is equal to 0 because we are pouring in fresh water. Now, I'm hoping, I think that's all that I still had to give to you. So I apologize for that. All right, let's go to the actual setup now. We did the interval, let's go to the setup. So Q1 prime, the concentration with respect to time of tank 1 is going to be equal to R1C1 plus our other inflow, which will be R4 times the concentration of tank 2 at any given time with respect to its volume. So our volume there is a constant, so that will just be over 300. And then we have to subtract out any outflow. So the outflow of R3 plus R5, and both of those will be using the concentration of tank 1 with respect to time, so our volume function at that given T value. This is the same as what I gave for your notes in class. So again, if you were unable to fill in those concentrations because I did not give them to you, I apologize. Hopefully we can get them now. So when I fill in all the known information, R1 times C1, I should have 10 times 1/2 plus rate 4, which is 6. And then Q, or Q sub 2, is what we are solving for, that function Q. So we'll do some simplifying there. R3 plus R5 would be 6. And then Q sub 1 is our function we're solving for, and our T is unknown. So that is kind of the simplest version of that right there. We'll simplify a little further with our fractions, and then we'll do the same idea here for Q sub 2. So I won't write out what I did for the full inflow plus outflow like I did above. You can check your notes for that. But we should be getting, for Q sub 2, 12 times 0 plus 2 times Q sub 1 over its volume function Okay, minus, we have outflow of R4 plus R6, so that would be 14 times Q sub 2 over its constant volume of 300. All right, so the simplified version of each of these, Q1 prime is equal to 5, acts as a constant, plus 1/50th Q sub 2 minus, and now this is an uglier function of t, but again, it fits into what we talked about in our notes with having those functions of t and then possibly using matrix form. So 6 over 200 plus 10t times q1. And so you can see we would probably rearrange that a little bit, get this into our matrix form as we mentioned in 4.2. And then q2 prime simplified a little bit would be 2 over 200 plus 10t times q sub 1 minus, and I guess you could probably reduce this, but I left in the notes 14 over 300 times q sub 2. And then we also have initial conditions on this because it gave us that we had tank 1 containing 200 gallons of fresh water and tank 2 containing 50 pounds of salt. So we didn't even touch that information. And again, this speaks to the concentration. So because I am solving for concentration Q, we want concentration at any given time. That is helpful for us. So that gives us our initial conditions that for Q sub 1 at time 0, the concentration of tank 1 at time 0, it was fresh water, so it's equal to 0. The concentration of tank 2 at time 0 was equal to 50, and that would be 50 pounds of salt. So the last time we talked about these tank problems, we did say too that it is very important to include units and to watch those units. The units can be tricky. But, you know, again, as you multiply R1 times C1, a rate times a constant, you have gallons per minute times pounds per gallon. So what you are looking at is pounds per minute. And the pounds are obviously our salt. And so that's why we want those initial conditions to be pounds of salt. Hopefully this is helpful. Let me know if you have any questions.